there are some nuances of j that deserve a little bit of additional attention. We're going to be using j in complex quantities, complex exponentials extensively in electrical engineering. We need to be comfortable with a few of these things. For example, 1 over j is equal to negative j. How do we understand that? Well, if you've got 1 over j and you multiply numerator and denominator by j, in other words, we're going to rationalize the denominator by getting rid of the imaginary part in the denominator, you come up with, in the numerator you get j, and in the denominator you have j squared. Well, j squared is negative 1, so that's equal to j divided by negative 1, or that's equal to negative j. So when you move the complex, the square root of negative 1 term j from the numerator to the denominator, or from the denominator to the numerator, you change the sign on it. Another one that deserves just a little bit of attention. E to the j90 is equal to j, and e to the minus j90 is equal to negative j. How are we to understand that? Well, in its polar form, e to the j90 can be rewritten in its rectangular form as it has a magnitude of 1, so it would be 1 magnitude of it times the cosine of 90 plus j sine of 90. Well, of course, the cosine of 90 is 0, and you're left with j times the sine of 90. The sine of 90 is 1, so e to the j90 equals j. Let's look at it in the complex plane. If we have a complex number, e to the j90, again it is something that has a magnitude of 1 and an angle of 90 degrees. So magnitude of 1, we're coming up here along the j-axis, the imaginary axis. We come up a distance of 1, angle 90. Well, that is simply 1j. Finally, when calculating the magnitude of a complex number, don't square the j. The magnitude of the complex number is the length, or the distance, of the point in the complex plane away from the origin. By definition and by nature, the distance or the length of something is a positive value. So when we're calculating the distance or the magnitude of z, we simply take and calculate the square root of a squared plus b squared. You don't put the j in there. For example, let's let z equal 2 plus j3. The magnitude of z is going to equal the square root of 2 squared plus 3 squared, which equals the square root of 13. What would happen if we did square the j? Well, this is not how you do it, but just to show what would happen if we did it wrong, we would have then, we would think that the square root of z would equal 2 squared plus j3 squared. Well, that would equal the square root of 4 plus, now j3 squared, squaring the j would give you a negative 1, squaring the 3 would give you a 9, so you'd have a minus 9. And if we were to do it this way, we would come up with the length of that thing being the square root of negative 5. Clearly, that's not what we're looking for. We're looking for the distance there. The distance is you come over a, whatever our dimensions are here, and you come up b, whatever those dimensions are there, and Pythagorean's theorem says that that distance is a squared plus b squared, square root of it.